Hi everyone, and welcome back to another weekly update on the Spectrum Game Tool. Back to a weekly schedule after last week's slightly longer delay. This week I've been mostly looking at animation. I've made some other changes, smaller changes around the tool, mostly in support of the animation, but the main focus is on animation of sprites. Hopefully this week a little bit less technical. I will go into a little bit of detail on the changes necessary in the generated C code aspect, but not quite as complicated as last week with all the memory management and all that entailed. So without further ado, I'll get into what's changed in the editor. A few small changes here, won't go into the details here, button there, but I'll explain those in a little bit more detail later. The most important change this time round is in the object editor, which is where the animations happen. So you may see some structural changes here. They don't come into play until you actually create an object, and you'll notice there's no longer a list of frames here, and that's because the frames are now contained within individual animations. So you can create an animation, it puts an animation into this list, and you can create multiple animations, and within the animation there's where you create your frames now, so you have as many frames as you like. This element here will display the animation playing once you add some frames. The green highlight shows which animation is selected, mainly for things like deleting. Okay, so if we go back quickly to the sprite editor and add some sprites, so we can do some basic animation, just do something very simple. Hopefully it won't take a moment if you stick with me. I have been through this a few times, so hopefully I'll be able to get it right without making any mistakes. So I'm trying to do a very simple spinny X with a minimum number of frames, just to make it look interesting, and it'll highlight something else once I get to the point. It'll highlight something else about the benefit of having multiple animations assigned to each object. So one more, this time with the angled version on the other side, on the other 45-degree-ish spin. Now we've got all 4 frames. If we go back to the objects, we can make sure we've got 4 frames and add them sequentially, and you'll see this is now showing the frames that are there and blank for ones that aren't, and it just runs at the moment at a fixed rate. I'll add controls for that later. So if we add all 4 frames, you have a basic spinny X. One small thing to note is this icon here is, I added this to allow you to insert frames within the sequence, because I found that was going to be very useful, or I felt that was going to be very useful. I will add some more controls down here to allow you to reorder frames, shift things around, or maybe some drag and drop, but for now that's what you get. So just to show the benefits of having multiple animations available on each object, so I can create a new animation, and very cost effectively in terms of memory, if I put them in a slightly different order, just basically flipping the two 45-degree ones, you have an X that spins in the other direction very easily, and it uses very little additional memory. So if I look at the code that's generated here, we'll see all the sprites, and then down in the object definitions, this is the new stuff that gets added. So you have an animation 0 and 1, which are basically just frame numbers within the sprite sheet. It has 4 as a count at the start, and then 1, 0, 1, 2, 3, 0, 3, 2, 1. So that shows the swapping of those 2 X's, and that's basically all that's necessary to do animation. The rest of the code's updated to read. You'll notice the object struct has a rate animation and frame automatically generated members. These are generated if there is animation. If there isn't animation, they're not, to save memory. So if you had an object that has no visual, then these just won't be generated, or if there's only a single frame, these won't be generated because it just saves on unnecessary memory. And then within the render, it would have code. The code that draws the sprite or moves the sprite would read these values and make sure that the right frame is drawn on screen. So that's how it works in terms of generating or creating the animations, and you can create as many of these as you like. So we can create another one. It scrolls down, so you can have different animations for different states for your player or for the enemy, all sorts of different things. And then in the logic, there's a new node that's been added, just a single one at the moment, but I will have others, that allows you to set the animation. It lists automatically which animations are available on the object that your logic is assigned to. 0, 1, 2 or 3, or 1, 2 or 3, sorry. There is a rate setting in here, but it's not used at the moment. The rate is fixed, but will be exposed through the code. So that's basically how that works. I'm trying to think if there's anything else worth mentioning in here before we go into actually looking at it in a more meaningful example. I mentioned a couple of things in the sprite editor that have changed. This one allows you to duplicate the sprite, so if you're doing lots of frames that are very similar with slight changes, you can just click on duplicate and you'll get a copy of that sprite with all the data copied, including any mask or anything else that you had in there, and allow you just to go in and tweak, so it makes it a lot easier. Someone on the forums did mention, or I think it might actually be in a YouTube comment, the idea of an onion skin effect for the sprite editor, particularly for this. That will be implemented, so you can overlay 2 frames within the within the editing panel, which allows you to much more easily define sequential animation frames and see how they play together. Any other tool ideas, please do drop a comment in the comments below. I'll make note of anything that you think might be useful in generating animated sprites or sprites in general. I think that's basically it for the major changes here, and I showed you the changes in the code. So if I quickly load up the default game, you'll see that I've made some changes in here. I've added more frames of our Manic Miner character, cleaned up some other stuff, and a second frame for the bubble. So if we go to the bubble object, you can see it has one animation that just toggles between those 2 states. The player has 2 animations, one for each direction, which we're going to use in the logic for defining which animation to play depending on the direction the player is moving. So if we have a quick look at the logic changes, this is where you can start to see the use of the new animation node in action. So a couple of things I've changed over here. Before we had this section of the calculation here gets the left and right buttons and then works out a direction based on the values of those buttons. Before, that would have gone straight into a final math addition that then is used to move the object, the addition being the x, the current x and the new direction. Instead, now what I do is I store that value off into a new variable over here that I've created called dir, direction. This means that because direction is now being used in multiple places, it's not recalculated multiple times. If I'd have just connected this over to the direction animation element of the logic, it would have recalculated all of this, which results in redundant code. So it stores it into a new variable now, and then uses that variable in both the move and in these 2 compares over here. So basically, dir will be -1, 0 or 1, depending on whether you're moving to the left, not moving horizontally at all, or moving to the right. So the first thing it does is check to see if it's 0. If it's 0, do nothing. Leave the sprite animating with the sprite animation as it is. So it doesn't automatically flip to facing right or whatever. It'll just, if you were last moving to the left, it'll keep you facing to the left, and so on. If it's not 0, then it checks to see if it's less than 0, which means it's moving to the left, negative in x. And if it's less than 0, it uses animation 2, which is this one, moving to the left. If it's not, which means it's greater than 0, then it uses animation 1, which is moving to the right. So this theoretically should mean that automatically now, as we move around in the game, it should select the right animation. The animation plays at a fixed rate, but the direction will be chosen based on what your move direction is. So let's export this now and pop over to our shell and make. Again, it's taking a little bit longer. I might get to a point where during these videos, if the compilation phase is starting to take too long, I might speed things up, but I think we're okay today. This may be the last time that we get a chance to do it like this, as long as I can keep thinking of things to say for the time it takes to compile. While it's doing this, just a quick reminder, please do take a moment to like, comment and share, and subscribe if you're interested in following on from these development logs. Okay, so that's finished compiling. So if we pop over to the emulator now and load the game, fingers crossed. So we've got animation to begin with, it's animating properly, and it switches direction as I move. Now the thing that bothered me when I first did this, and it was my fault for the way that I drew the sprites, there's too much of a jump when you swap direction. It shouldn't really jump like that. It should pivot on the spot, or in my opinion it should anyway for this particular game. So that leads us neatly back to the other change that some of you may have noticed, is this new mode on here. So if we go to our sprite, it's slightly offset to the right, just the way I drew it. So now we have this tool, so we've got paint, mask and now move, which allows you to move the mask and the sprite around. It wraps around so you don't lose anything, it just moves all the data. So if we aim to get it 1, 2, 3, 4, 5, 6, 7, so let's say 8. So that's the halfway mark on the 16 by 16, so it's just to the right of it. So if we pick the other frames, we can see that's off by 1, so we can very quickly shift the whole thing across, and the same with that one. So the eye is always on that first column in the second set of characters. The left facing one is more offset, so 1, 2, 3, 4, 5, 6, so we want it over here, which would be on the last one in the first column. So we move that over, and then this one similarly, and that one. So they should all be aligned now, and if we go back to our object, it should all look good, but it's just much more central. And if we re-export quickly, and do another compile, I'll fast forward past this. All done. And then if we switch back to the emulator and load a new one, we should see everything's the same, except the switch between left and right direction is much less jarring now. He more or less moves on the spot. You'll notice the balloon is also, or the bubble is also animating, because it's the same object with the same animation sequences defined by default, and it will automatically play animation sequence 0. All the bubbles animate in the same way with no significant effort. Everything else should still work, so firing of the bullets, although they only fire in one direction irrespective of where you're facing at the moment, that's just a matter of the logic not being defined to choose direction at this point. But everything else seems to be there, so another step towards something I think that could very soon become usable, and another step towards the alpha test. So again, as I've mentioned in the last couple of videos, if anyone is interested in getting some early access to this and tinkering with it, on the understanding that it is very early days, very work in progress, alpha quality software, please do let me know on Coffee or in the chat, in the comments below, and I'll add your name to the list of people who have expressed an interest. Again, please don't forget to subscribe, hit the like button, and I'll see you next time.